All right, question 10. This is another command of evidence question, but this type is the quantitative type, not the textual, the quantitative. Now that's College Board's wording for it. We'll call it infographics. But basically, question 9 and question 10 are the same in that there is a claim in the passage. Let me see if I can find it here. It's probably down here. So this guy says something, and then we need some evidence from the table to support it. So in both cases, you're just finding evidence to prove a claim in the passage. Okay, so where do you begin with this type of question? You know what? You begin with the graph, with the infographic at top. That's why they put it at the top. Now on the current SAT, they put it at the bottom, but here it's at the top because if you read it first, you'll have better understanding of the passage. Now, it's not always easy to wrap your head around this information in the graph, so it doesn't always work, but let's try. Ablation rates. Like for example, I don't know what that means. I think I have to actually look down into the passage later on to figure out what ablation is. But I get that this is ablation rates for 3 elements in cosmic dust, and I can see 3 elements in dust. And I generally, just from looking over it very briefly, I noticed that, wow, this is all pretty high, and this is all pretty low on the other side here. So that's something I noticed right away. And I think having that kind of just basic idea really informs your understanding of the passage. So when you go to the passage, you'll probably understand it a little bit better having viewed it first. So that's my recommendation to you. Good thing to write down if you're taking notes. Okay, so let's have a look at the passage since we don't know what ablation is. Maybe you do, I don't. Earth's atmosphere is bombarded. Good word, bombarded. Hit, like you can imagine bombs. Bombarded with cosmic dust originating from several sources. SPCs, ASTs. That would be the first 2 here. HTCs and OCCs. And that would be the other 2. Okay, so we've just gone through all 4 there. Some of the dust's material vaporizes from the atmosphere in a process called ablation. Okay. So ablation is when the dust just disappears. It evaporates in the atmosphere, just like I'm saying. And the faster the particles move, the higher the rate of ablation. So I guess that means these are really fast and these are slow. So astrophysicist Juan Diego Carrillo Sanchez led a team that calculated the average rates for elements in the dust and showed, okay, what did he show? Material in SPC or AST dust has a lower rate than the same material in faster moving dust. This dust. Okay. It's hard for us to wrap our heads around that, or at least it's hard for me to wrap my head around that. They're saying that this material has a lower rate, seems to be true, than the other ones which have a higher rate, seems to be true. For example, whereas the average ablation rate for iron from AST dust is 28, the average rate for blank. So we need to compare something that is the same material in the faster moving HTC or OCC dust. So if we need to find OCC or HTC, that means we cannot be finding the other 2 types of dust. So I'm going to kill A and D. Okay, secondly, we have to make sure that this is the same material. They're comparing the same material. So if the ablation rate for iron is 28, let's compare it to iron. Iron is right here. The answer therefore must be C. And hopefully I'm not going too fast here. Let's say that one more time. Slower moving dust is having a lower rate than the same material when it's faster moving dust. And so iron, when it's this type of dust, 28%, is slower than the average rate for iron when it's HTC dust, which is faster dust, and it is higher. So that must be the answer. C, final answer, and we'll move on there.